Today we're going to do discussion number 2 for Math 260, and in this discussion we're asked to derive a formula based off of cosine of beta less alpha, and we're supposed to find the formula off of this using two vectors and the dot product. So there's a few things there's one thing that we're given, that is v equals cosine of theta I plus sine j, or sine theta j, equals v, which one of the vectors. So in order to display how we're going to find this, we should make a graph. So here's our graph. Let me try to do it over here. Alright, so we're going to have one vector going off this direction, call it v1, then another vector going off this direction, we'll call it v2. So what we see here is we have two angles. We have angle right, well, we have three, but we have one angle right here, we'll call this alpha, and we'll have one angle off of here, we'll call it beta. So, and then if we see, what we see here is our two angles, and then we can write another one, which is the angle in between these two vectors. We'll call that theta. So, for what we know, with this display here, we can see that theta is equal to beta minus alpha. So this is something we can consider when we're driving our formula. So one thing we'll do, as well as, I'm going to use this marker, I'm going to write out, we're going to have two vectors. We'll have a formula for v1 equals cosine, and then angle between the positive x-axis and the vector itself. We'll have that plus sine theta, sine alpha j. There's our v1, and then v2. It's going to be the same thing except beta. So we have our two formulas here. So now we're going to apply a formula that we learned in this unit, and that is use this marker again. That is going to be cosine of theta equals dot product of, this could be dot product of A and B over the magnitude of A and B. But for this demonstration, I'm going to use vector 1 and vector 2. So we're going to have vector 1, vector 1 dot product of vector 2 over magnitude of vector 1, magnitude of vector 2. So that's our formula. So what we see is on the unit circle, a vector will only go out to, at least with this formula, a vector will only go out to a magnitude of 1. So if you draw a unit circle, kind of an ellipse, but we see that our vectors will only go out to a magnitude of 1 on a unit circle. So that means our magnitude for vector 1 and vector 2 is going to equal 1. So that means, so that means we have cosine of theta. Well, actually, we'll do this. v1, v2 times cosine theta equals dot product of v1 dot v2. Which, since this is going to equal 1, we're going to have cosine of theta equal v1, v2. dot v2. So that means we can apply our formulas up here for the vector cosine alpha I and sine alpha j, and the other one to our formula here. And then we'll also take this formula right here and apply it into our theta. So beta minus alpha equals cosine alpha I, that's j, cosine alpha I plus sine alpha j dot cosine beta I plus sine beta j. So, and then when we do the formula, we'll end up with cosine beta minus alpha equals, we do the dot product, cosine alpha I times cosine beta I plus sine alpha I times sine beta j, or sine alpha j. That's not right. There it is. So now this is our formula. This is our formula that we derived from this, well, from this formula up here, and that's our answer.